Hey everyone, buckle up because today we're blasting off into the wild world of astrophysics.
Sounds exciting.
It is. We're taking a deep dive into a discussion from Neil deGrasse Tyson's StarTalk, and let me tell you, this one's going to really challenge what you think you know about time and space.
Oh, yeah, we think we know it all, don't we?
Right. Like something as simple as now, for instance. We just assume there's like a universal now happening everywhere at the same time.
It seems logical, right?
Right, but what if that's completely wrong?
Well, that's the thing.
Okay, you got to explain this to me.
It all comes down to this crazy idea called the relativity of simultaneity.
Relativity of simultaneity. Okay, now that sounds very complex.
It sounds complicated, but it's pretty simple, the basic concept.
Okay, break it down for me.
All right, so picture this. Two people are watching a rocket launch, but one of them is on a speeding train, and because they're moving, the person on the train might actually see the rocket lift off a tiny bit earlier than the person standing still.
Okay, I'm with you so far, I think. But how does that prove there's no universal now?
Well, that's just a tiny example, right? Einstein's theory of relativity tells us that the faster you move, the slower time actually passes for you relative to someone who's not moving.
Wait, hold.
It's kind of like the universe has this cosmic speed limit, you know?
Oh, wow.
And as you get closer and closer to that limit, time itself starts to warp.
Whoa, are you telling me there is no single now? So like what I think is happening right now, like right this second, could be totally different for someone on a distant planet.
Exactly. That's exactly it. There is no one moment that everybody everywhere agrees on.
Wow.
What we experience as now, it totally depends on where we are and how fast we're moving.
That's crazy. I've never thought about time that way.
It is kind of wild.
So how do we even begin to think about like events happening across these huge distances when time itself is relative?
Well, that's something astrophysicists struggle with all the time.
I bet.
And luckily, Neil had a really great guest on StarTalk who can help break it all down, Dr. Hakeem Oluseyi.
Dr. Hakeem Oluseyi, such a brilliant astrophysicist. And at the time, he was also heading up the Astronomical Society of the Pacific. And just as a side note, they are not your typical stuffy scientific organization.
Definitely not.
Not at all. They're all about getting everyone excited about space, no matter what their background is.
Right.
The ASP, they're all about public outreach, collaborating with people.
Anyone can join.
I love that science shouldn't be locked away in some ivory tower.
I agree with that.
And speaking of, being open and having conversations, I really enjoyed that little back and forth in the episode about the difference between nerds and geeks.
It was kind of funny.
It was fun, right? They were
Yeah.
playing with those labels a little bit.
Right. So as they were discussing it, it seemed like a geek is somebody with this deep, focused passion for a particular subject.
Okay, so like a comic book geek, history geek.
Exactly. Could be anything.
Yeah.
Star Wars geek, you name it.
Okay, so geeks have their laser focus, but what about nerds? Where do they fit in?
Well, nerds are more like those knowledge sponges. They just have this endless curiosity that drives them to explore all kinds of different topics, even things that most people wouldn't even think about.
So geeks go deep and nerds go broad.
That's a good way to put it.
And I guess we all fall somewhere on that spectrum. What about you? Where do you think you land?
Oh, a little bit of both, I think.
Me too. Me too. It's hard to choose.
It is.
This whole nerd versus geek thing, it got me thinking about, like, the ultimate nerds, the ones who are actually sending spacecraft out to study the edge of our solar system.
Like with the IM mission.
You're talking about the Interstellar Mapping and Acceleration Probe.
Yes.
That's a real NASA mission, folks, and it's all about studying the heliosphere. Now, for those of us who aren't astrophysicists, can you explain what exactly is the heliosphere and why should we care about it?
Sure. So think of the heliosphere as our solar system's bubble wrap. It's this giant bubble created by the sun's solar wind that basically protects us from all the harmful stuff floating around in space.
So it's like a giant force field protecting us from cosmic rays.
Pretty much, yeah.
Okay, but why are scientists sending a whole mission out there to study it?
Well, because it's not static, it's constantly being pushed and shaped by this pressure from interstellar gas and the galactic magnetic field.
I see.
IMP is trying to figure out how particles accelerate at that boundary of the heliosphere where the solar wind crashes into interstellar space.
So it's like figuring out the dynamics of a cosmic tsunami.
You could say that.
Wow. Okay, and knowing that is crucial for protecting astronauts on future deep space missions, right?
Exactly. Think of it as mapping out the cosmic weather so we can safely navigate the vast interstellar ocean.
That's a great analogy. I like that. But here's a question. How do scientists actually study something as vast and kind of elusive as the heliosphere?
Good question.
It's not like they can just fly out there and take measurements.
It's tricky, for sure, but this is where things get really interesting.
Okay, lay it on me.
Scientists are particularly fascinated by these tiny things called neutral atoms out in space.
Neutral atoms, okay?
And these atoms hold the key to unlocking the heliosphere's secrets.
I'm intrigued. Why are neutral atoms so important?
Because they're like the ultimate cosmic spies.
Cosmic spies, I love it.
Right, they can travel through magnetic fields undetected, bringing us information from places that we could never reach with spacecraft.
So they're like our secret network of informants across the galaxy.
Exactly.
I love that analogy. So these neutral atoms are like tiny messengers coming from the edge of our solar system,
That's a good way to think about it, yeah.
carrying secrets.
Carrying secrets, that's right. They bring back information about the heliosphere's boundaries, the density of interstellar gas, and even the strength of the galactic magnetic field.
Wow. And so how do scientists actually read these messages that are carried by the neutral atoms? It's not like they're sending us text messages, right?
No, it's more like deciphering a cosmic code.
I see.
IMP is equipped with these incredibly sensitive instruments that can detect these neutral atoms and analyze their properties. By studying things like their energy levels, what direction they're traveling in, and what they're made of, scientists can put together this detailed picture of what's happening out there at the edge of our solar system.
It's like having a cosmic microscope. Wow. So we can see the invisible forces shaping our neighborhood.
That's a great way to put it.
This is all so fascinating, but I have to admit, my brain is starting to feel a little bit overloaded. We've gone from questioning the very nature of now to exploring the boundaries of our solar system and the secrets hidden within these tiny neutral atoms.
It is a lot to take in.
Yeah, and that's the beginning. There's so much more to unpack in this episode, so stick around for part 2, where we'll explore even deeper into these cosmic queries raised by Neil deGrasse Tyson and Dr. Hakeem Oluseyi.
Definitely a lot more to explore. Welcome back, everybody. I hope you're ready for more because we're going to go even deeper into the cosmic mysteries that Neil and Dr. Oluseyi discussed on StarTalk.
I'm ready. Bring it on.
All right, so we've been talking a lot about what's happening out there at the edge of our solar system, but they also talked about some truly massive, like almost unimaginable structures that could exist in the universe.
Like what?
Dyson spheres. Have you heard of those?
Dyson spheres. The name rings a bell, but I can't quite remember what they are.
They're like straight out of science fiction.
Oh, yeah.
But theoretically, they could exist.
Interesting.
Picture this, a civilization so advanced that they've built this giant structure completely surrounding a star to capture its energy.
Wait, you mean a structure built around an entire star?
That's the idea, yeah.
That sounds impossible. How could anyone even think about building something like that?
It would be a huge undertaking, no doubt about it.
Yeah.
We're talking about, like, a sphere of solar panels, something like that, completely enveloping a star like our sun, capturing all that energy.
I mean, I get the appeal, unlimited energy, that's pretty enticing, but even if it's possible, we're nowhere near being able to build something like that, right?
No, not even close. It's totally hypothetical at this point.
Okay.
But it does raise some really interesting questions about what advanced civilizations out there in the universe might be capable of doing.
Yeah, that's a great point. If we ever actually detected something like a Dyson sphere, that would be a pretty clear sign that we're not alone in the universe.
No question about it. It would be a game changer.
Yeah, for sure.
And this leads to another really interesting idea that they discussed, the idea that maybe, just maybe, our understanding of physics is just this tiny little piece of the whole picture.
Okay, now that is a humbling thought. What do you mean? Are you saying that the laws of physics might be different in other parts of the universe?
That's exactly what I'm saying. We tend to assume that the laws of physics are universal, right? That they're unchanging.
Right.
But what if those laws are just local rules, rules that apply to our little corner of the cosmos?
So there could be, like, whole regions of the universe where gravity works differently or light behaves in ways we can't even imagine.
Exactly. It's mind-boggling, isn't it?
That's crazy.
It's like thinking that we've mapped the entire world because we've explored our backyard.
Oh, that's a good analogy.
There could be whole continents of knowledge out there waiting to be discovered, with physics bending and warping in ways we can't even comprehend.
I'm starting to feel like everything I thought I knew about the universe is being turned upside down.
Well, that's the exciting part.
Yeah, it is, in a way.
It means there's so much more to learn, so many more mysteries to unravel.
This whole conversation, it reminds me of something that I've always wondered about: dark matter and dark energy. We know they make up the vast majority of the universe, but we can't see them. We can't directly detect them.
Right.
What if they're just manifestations of these different physical laws operating in ways that we don't understand?
Now, that's an interesting idea. It's like those optical illusions where your brain tricks you into seeing something that isn't really there.
Right, right.
Maybe we're misinterpreting the data because our understanding of physics is incomplete.
So maybe dark matter and dark energy aren't so mysterious after all. They just seem that way because we're looking at them through the wrong lens.
It's definitely a possibility worth considering.
Let me ask.
And it just goes to show how much we still don't know about the universe and how much more there is to discover.
Absolutely. It's both exhilarating and humbling at the same time.
Exactly.
Speaking of humility, I remember Dr. Oluseyi emphasizing how important scientific curiosity is. He made it clear that asking questions is just as important as finding answers, maybe even more so.
Yeah, I love that point. He used this great analogy about a jazz band.
Oh, yeah. Tell me about that.
He compared scientists to musicians in a jazz band, where each player brings their own unique skills and improvisational talents, creating something much greater than they could on their own.
So it's not just about playing the notes as written. It's about improvising, exploring new possibilities.
Exactly. Science is this collaborative effort where sharing ideas, challenging assumptions, and building on each other's work, that's how we push the boundaries of our understanding.
That makes a lot of sense. And we can't forget the role technology plays in all of this.
Of course.
Think about the IMP mission. It relies on cutting-edge instruments to detect those neutral atoms we were talking about earlier.
Right. Technology is the key that unlocks new doors of understanding.
It allows us to observe the universe in ways that we couldn't have even imagined a few decades ago, from the tiniest subatomic particles to the most distant galaxies.
Yeah, it's incredible what we can do now.
It's like we're constantly upgrading our cosmic toolkit, enabling us to see farther, deeper, with more clarity than ever before.
Absolutely. And as technology advances, so too does our understanding of the universe.
It's a beautiful relationship.
It really is. It's a symbiotic relationship that keeps driving us forward on this never-ending journey of cosmic exploration.
You know, one of the things that really struck me in this episode was the genuine sense of awe and wonder that both Neil and Dr. Oluseyi expressed. It's clear that they're both deeply passionate about their work, and they're really excited to share that passion with the world.
It's contagious, isn't it?
It is.
Their enthusiasm reminds us that science isn't just about cold, hard facts.
Right.
It's about the thrill of discovery, the pursuit of knowledge, and that profound sense of awe that comes from contemplating the vastness and complexity of the universe.
It's like they're inviting us all to join them on this grand cosmic adventure, encouraging us to marvel at the wonders of the universe and never stop asking questions.
That's a great way to put it, and that's exactly what we're trying to do here on the Deep Dive. We want to ignite that same sense of curiosity and wonder in our listeners.
Because we're all explorers in our own way, whether we're peering through a telescope or just contemplating the mysteries of the cosmos from our living rooms.
That's right. The universe is vast and full of secrets just waiting to be uncovered, and the more we learn, the more we realize how much more there is to know.
Absolutely. So keep those minds open, folks, because the journey of cosmic exploration is just beginning. Which brings me to a big question. If the universe is so vast and ancient and there's so much potential for life out there, then where is everybody else?
Ah, yes, the Fermi paradox, the ultimate head-scratcher. We've been searching for signs of extraterrestrial intelligence for decades now, and still nothing conclusive. It's like we're shouting into this cosmic void, but nobody's answering.
I've definitely thought about that a lot. It's both exciting and a little unsettling to think about us being alone in this huge universe.
Maybe we're just looking in the wrong places or listening on the wrong frequencies.
So you're saying it's possible that alien civilizations are communicating in ways that we haven't even thought of yet?
It's possible. Or maybe our definition of what intelligent life is too narrow. Maybe there are forms of intelligence out there that are so different from our own that we wouldn't even recognize them as being intelligent.
It's like we're surrounded by alien life, but we just don't have the tools or the understanding to perceive it.
It's a mind-blowing possibility.
It really is.
And the Fermi paradox, it just reminds us that we still have so much to learn about the universe and the potential for life beyond Earth. It's a call for humility, but also an invitation to keep searching, keep listening, never give up hope that we're not alone.
You know, I think sometimes we get so caught up in searching for answers that we forget to just appreciate the mystery itself.
I agree, the unknown, that's what drives exploration and discovery.
And we're not done exploring yet. There's still more to come in this deep dive. Stick around for part 3, where we'll tackle some of the most thought-provoking questions raised by Neil and Dr. Oluseyi, from the practical implications of time dilation to the interconnectedness of all these seemingly different scientific fields. Welcome back, everyone. We're in the home stretch now of our deep dive into Neil deGrasse Tyson's StarTalk conversation with Dr. Hakeem Oluseyi.
And we've saved some of the most, I'd say, mind-bending and practical topics for last.
Practical, now you got my attention. When we talk about these huge cosmic concepts, it's easy to forget that they can actually have implications for our everyday lives.
Right. Like, remember when we talked about time being relative? You know, how it depends on your speed and location in the universe?
Yeah.
Well, that's not just some abstract theory. It's something we really have to think about if we ever want to travel beyond our solar system.
Wait, so you're saying the theory of relativity has real-world implications for space travel?
Oh, absolutely. Imagine you're on a spaceship traveling at, like, a significant fraction of the speed of light.
Right.
Time would actually pass more slowly for you compared to someone back on Earth.
Hold on, are you saying time travel isn't just science fiction? Could we actually come back from a deep space mission younger than our twin brother or sister who stayed on Earth?
That's exactly what time dilation suggests. It's a consequence of the theory of relativity.
Wow.
And it's not just hypothetical either. We've actually observed this phenomenon with atomic clocks that have been flown on high-speed jets.
That's wild. So if we ever figure out how to travel near the speed of light, time travel might actually be possible.
It's definitely a possibility, but even at more, reasonable speeds, the effects of time dilation would be significant for interstellar travel. Mission planners would have to account for those time differences between the crew and the people back home.
It's mind-blowing to think that something as fundamental as time can be so fluid, but now I'm also realizing that we've been talking about time and space as if they're separate things,
Yeah.
but maybe they're more interconnected than we realize.
You're right. We tend to think of them as distinct concepts, but they're really intertwined. It's more accurate to think of it as space-time, this four-dimensional fabric that can be warped and stretched by gravity.
Okay, now my brain is really starting to hurt, but I love how these ideas challenge everything we think we know about how the universe works.
That's the beauty of astrophysics. It forces us to think bigger, to see the universe in new ways.
And speaking of expanding our thinking, we've covered so many different topics in this deep dive. We've talked about the relativity of time, Dyson spheres, the search for extraterrestrial life, the importance of neutral atoms, even the nature of scientific curiosity itself.
It might seem like a random collection of ideas, but there's a common thread that connects them all. It's this pursuit of understanding where we fit into this grand cosmic scheme.
It's like we're putting together this giant cosmic jigsaw puzzle, and each of these topics is a piece of that puzzle.
Exactly. And the more pieces we find, the clearer the bigger picture becomes.
And even though we've learned so much, it still feels like we're just scratching the surface.
That's the beauty of science. It's a journey of endless discovery. Every answer just leads to more questions, pushing us to explore further and deeper into the mysteries of the universe.
Well, on that note, I think it's time to wrap up our deep dive into this fascinating StarTalk episode.
It's been a great journey.
It really has.
I hope our listeners have come away with a new appreciation for the vastness, the wonder, and the mystery of the cosmos.
And maybe even a little bit of that existential awe. So as we sign off, what's the one thing you hope people take away from this deep dive?
I hope they leave with a sense of curiosity and wonder. I hope they remember that the universe is full of surprises, and this journey of exploration, it's really just beginning.
I couldn't have said it better myself. Keep looking up, keep asking questions, and never lose that childlike sense of wonder. Who knows what incredible discoveries are waiting for us just beyond the horizon.